My talk has no match to the dance, to dancing. And, yeah, that's the difficult part. I'm in the field of engineering and technology. So, basically, as engineers, we are boring people, really boring people. We're working on serious problems, hopefully arrive to serious solutions. And the topic this hour, is food waste. Is one of a serious problem to urban sustainability. So the topic is turning food waste into valuable products. Basically, I want to talk about rethinking waste and rethinking new possibilities for urban sustainability. Food waste, well, everyone knows food waste. They wasted food before and after cooking or before after consumption. And the problem is the huge production of the food waste, like 1 billion. It's no exact figure number for this. It's over 1 billion or something, over 2 billion tons per year. China certainly is the biggest one. It's not one of the biggest. It's the largest food waste producer, and food waste is the last portion of urban waste. So the problem is the food waste, the volume keep increasing. It's simply too much. Like Shenzhen is over 5,000 tons per day. So it's a huge, fast-growing, and highly difficult to deal with because it's wet and high organic contents. But food waste is not a new problem. It has been around for years. So there are traditional, conventional solutions, but they are no longer working. And the method working in the past cannot deal with today's problem. It's a challenge. It's like landfilling. That's not me. That's not me. Landfilling and composting, because those methods, there are methods that are not going to work because they are too slow, and the yield produce little return, little value. So talking about the value, getting to the focus of this talk is rethinking food waste as a resource, because food waste, is really rich in valuable, good organics, not dirty, bad organics, good organics. So their potential for resources recovery, we call it valorization. So turn waste into valuable resources, resourceful products, like highlights here is bioenergy is one, or valuable or value-added chemical product. So basically, it's not waste, and they just need a solution to turn waste into valuable product. In fact, so nowadays, this new solution, so-called new solution, it's not that new, but they're already in place. So it's the solution, it's a pathway of food waste to energy through anaerobic digestion. Anaerobic digestion basically uses biological power to break down organics into smaller molecules like methane. And methane can be used as fuel for electricity generation. So some estimated this was sufficient to provide the electricity for 1 to 2% of the population, domestic use. So that's is one of resources recovery. So food waste to energy. But this is not high value resources recovery. So natural gas is not as expensive. The value is limited. How about high value products? So that's the focus of recent studies. There are many studies, many research on different technologies for the conversion of food waste into different high value products. Some examples are followed. Like again, on anaerobic process. This time it's not complete digestion, it's fermentation or we call it acidogenesis. So we convert waste, food waste to organic acid. Organic acid. This is a simple, natural, low cost, produce acid like a volatile fatty acid, VFAs, with a value like 200,000 yuan per ton. 2,000 yuan, that's a decent money. And it's a platform chemical for the synthesis of many valuable products, or used as a carbon source. Carbon source for what? For denitrification in wastewater treatment. So for the removal of nitrogen from wastewater, it's important for wastewater treatment and for water pollution control. This is one example. Something we have been working on this. And go one step further is the synthesis of plastic. We call it biodegradable plastic from food waste through biosynthesis, as shown here. So VFA already produced. That is the feeding substrate for the next step of biosynthesis, produce PHAs. PHA is more valuable, 20,000 yuan per ton. It's a more valuable product, and it's a function as a biodegradable plastic, has a bright future, because it's going to largely to replace those typical plastic, which is fossil fuel-based plastic. Similar to that is again anaerobic production of lactic acid. Lactic acid is precursor for another biodegradable plastic, that PLA. So it's another pathway for the conversion of food waste, again, the organic matter to more valuable organic product, which is biodegradable to replace conventional plastic, to eliminate many environmental problems for the sustainability. And that's just a part of a story, one part on the organic part. And in food waste, also rich contents of nutrients. This can be fixed into this protein product, like a yeast. So sterilization at the beginning and the inoculation of a proper yeast species produce single-cell protein as the animal feed or ingredient into animal feed. And this thing carry higher value and useful and provide whole package of conversion of food waste to high value product. And that, again, that's the photo show the product we obtained from our study, produced in our study. So basically yeast cells. Talking about yeast fermentation is part of is type of fungal fermentation, and the use fungal fermentation we can go a little bit further. This is interesting. Again, start from waste, food waste, sterilization by heating, then applying fungal fermentation. So fungal is the species. Fungal to basically produce fungal hyphae, actually high fungal fiber, microfibers. So those fibers are good things. After drying, they can be used to produce paper, cardboard, those things, like showing here. Down here, you can see this fungal pellets. And after breakage, and those things can be used for making hyphae paper or cardboards. Or packing material for valuable use. It's okay cost, like 20,000 yuan, those kind of cost. It's good recovery. And for this thing, it's a high conversion. So basically the waste to fungal cells, the production is high and easy separate. The separation is simple and the cells are already product. There's no bioproduct and cost effective. And go from here, already get a carbon fiber, already get the organic fiber. Then by carbonization, this is something currently we are working on. So convert those things to carbon fiber. Carbon fiber. This can be used as one example is carbon electrode for batteries or high capacitors. So we convert food waste through a couple of steps to high performance carbon electrode. And this one really carries high value, up to 100,000 yuan per ton. So you get a good product. And alternative to that, there's another fast process. We are not working on this, but just from the literature, they offer another approach. Is rapid conversion of food waste to valuable product through pyrolysis. Pyrolysis is basically the heating treatment without oxygen, so really break down organics, like food waste organics, into different small products, like in gaseous phase, some gas, like a fuel, or in liquid phase, bio-oil, and solid phase, like a biochar. A typical feature is rapid treatment. This thing is quick, hours complete treatment, and waste reduction, great level of waste reduction. So provide another option for the valorization of food waste. So anyway, food waste is a nasty problem, but again, with technological innovation, we can create more possibilities for urban sustainability. That's my talk. Thank you. Thank you.